Constantin is the director of the Center of Digital Technologies and CAD/CAM at the DPU University in Austria. I'm very happy to have you here today. Constantin, you have been involved from the very beginning into this project. You're one of the global experts in 3D printing in dentistry, so you have inspired us a lot, so we very much enjoy working with you today. So I'm very happy to welcome to the stage Professor Constantin von See for his TRITalk with the title, The Future of 3D Printing. Thank you, Constantin, for coming.
This one. Okay, thanks. So, when I was introduced to give a lecture here in Zurich, I tried to kick myself back a little bit in time. And we talked about 10 years of research now coming to the product which we launch here. And when it comes to additive manufacturing, or 3D printing as you might call it, there's always the buzzword disruptive. But disruptive in the way forth, let's take a look back. And I just remind myself, when I was here talking to Sandro, who introduced me, thank you so much, where do we start? And I found a very old book of mine, with a different logo that days, and these are the first sketches in 2017, where we started to draw, where we started to innovate, having a Coke, sitting on the beach and making up our minds. So, this is the beginning, 2017, in July. And now we are here and having a product. And this, of course, brings us to disruption in implantology. Because on that day, we decided not to take tiny steps of improvement, but to ask full questions. To ask the full question, do we need an abutment at all? And to change the way we look at things totally, meaning taking the new methods into account and designing an implant that meets these methods and not the other way around. And this was so disruptive, this was so innovative that I just jumped right in and said, this is my project, I want to join. And so, when we talk about additive manufacturing, when we talk about rapid prototyping, 3D printing is the method of choice. Absolutely. And so, the time lapse coming from, on the one hand side, an idea to the product is really diminished today. Why? Because of 3D printing. Because from the idea to a design, Raphael, thank you, and from the design to printing is just an hour away. And this is what makes the whole process not only innovative, but disruptive. If you want to have a look back in the timeline of 3D printing, it started in 1986. This is not really long ago for a new method evolving. And then in 2009 and 2014, some patents ran out. And from there on, there was a big boost in the whole situation of 3D printing, which was, of course, accomplished by faster computers, by more methods, by artificial intelligence emerging on the same stage of production. And so, when we talk about 3D printing as a full stage, there are so many methods that evolved from there on. So when we talk about sizes in printing, we can print houses in macrostructures, whereas we can print for tissue engineering tiny, tiny structures. So there is not really, technically, a border of dimension, not for dentistry. And so, where are the limits? Where are the limits in free forming when it comes to the sides of additive manufacturing? I don't know. So, just as a saying, just as a quote, we always mean in our lab, give me an STL, I will print it. So, from the technical side where we jumped in, of course we have some limitations. But what we can do now is individual, rapid prototyping in an instance. Individualized, customized products, and we heard this quite often today. Dental technician work is exactly individualized, customized products. So you see here, this was our first full printed, permanent restoration in the patient's site on this matrix implant. Of course, as a researcher, I have to say, prior to clinics comes research. You heard about the in vitro testing. We did our tests, and I can full assure you that what we have today is not what we had in vitro on our minds in 2017. So of course we did, as I always say, our homework in vitro first, testing, optimizing, but even this in a very short time scale because of 3D printing. So we tested bone level, tissue level, we tested the forces in the permanent and temporary printable materials from today, and check mark, done. Full stop, it works for clinical use anyway. And from there on, we of course had ourselves always compare additive manufacturing to milling. And we see some kind of contradiction from the methods and from the opportunities which we have here. So if I want a very sharp edge, additive manufacturing is not the method of choice. If I don't want to have any garbage because I just print what I need to have, 3D printing is the method of choice. And so when we ask ourselves what happened in the last years in 3D printing, we have to see about production time. This was reduced about 1/4 in the last 6 years for dentistry. We have to talk about investment costs. So buying a 3D printer today is 1/10 of the cost from 6 years ago. We have to talk about post-processing, which still is a very, very difficult topic today. So is it really precise or nearly precise? It's more and more in the post-processing. In the way the dental technicians do their work, they understand the knowledge, the nesting, the software behind the design. And please don't underestimate IT knowledge. Of course, it looks like you can print anything, but in fact it means you can print anything if you have the knowledge you need for materials, for temperature, for design, for nesting, for slicing, then you have a precise outcome. So, of course you have to learn. There is a learning curve in 3D printing, but there was a learning curve in milling as well. So, as I explained now, you might get the idea that milling to printing is somehow contradictory. But let's look a little bit further from here on. It is not. So the first machinery already available, and I got this slide from the dear colleague, thank you so much, about the combination of additive manufacturing on the one hand side, so sinter laser melting or selective laser melting, meaning metal powder melted to a full metal structure, combined with the after-work processing of milling is already on the market. So we have already the combination, let's say the best of both worlds, from milling and additive manufacturing. And so we have huge opportunities here to really get the next step forward that came, honestly, within the last 3, I don't know why I show it like this, but anyway, the last 3 years of development from rocket science. The first thing I saw was like this, was NASA doing this to dentistry. So we can already use this method in dentistry and we'll optimize it there anyway. Another big issue is, of course, materials. 3D printing. Most of us think of the really disruptive techniques in resin printing. But of course, printing, additive manufacturing means metal printing as well. And 4 years ago, I was really quoted for saying, okay, resin will be printing material and milling will become something just for ceramics. Today, I have to revise my sayings there because we have already the first printed ceramic materials for dentistry. So, coming to the materials of choice within the printing era, we nearly have all the opportunities available which we have and need for our prosthetic restoration in either the milling or the printing way on the way. And this is enormous. And I don't see a limit really there in the printing. Of course, things like multi-layer printing. They are just tiny steps. They make their first work. They make their first ideas, and it is not ready for market yet. But there are some industries that are already working on combining different material, combining ceramics, combining colors. And this, of course, in the individualized, customized process is something that we really can take on in additive manufacturing. Where does this all lead to? As we have to take into consideration that the geometry strongly relies on the manufacturing process of the whole prosthetic restoration, we came for today, and I will say just for today, to the conclusion that for polymers we need a different screw type, a screw design, compared to ceramic today. Maybe this will change, but today, in what we have in 3D printing, in resin techniques, in polymers, it is advisable to use the screw necessary to really put all the forces smoothly on the surface. And so, it is not by accident that the geometry looks like it is, and that it's different, because we have a material which we always aimed for in implantology. And I looked it up in the books. Since the early 80s, we are searching for a softer material to reduce bone stress. And now we have a printable material that in our tests withstand 1.5 to 2 millimeters prior to breakage. So we have something more flexible, which especially for direct restoration seems absolutely beneficial to me. So, summing this all up, in our patients' cases, in what we were aiming for, this is all brought together from research, from in vitro, from the desk to the patient's mouth. Of course, with the surgical guide printed, what should I say? And so we have engaged and non-engaged implants restoration placed, and so they are happily all intact, printed with permanent material. And we're very much looking forward to follow up all these restorations to see the benefit of the outcome, because the simplicity of the whole process, the simplicity of the planning and the doing, which is very closely correlated today, is obvious already. And so, scanning to restoration, immediate restoration, becomes more feasible, and I think in the near future, not only more affordable, but patients benefit for especially aesthetic restoration and giving back function without overloading or without risking the overloading from the very first step. And so I'm very proud and happy to be part of this team, designing, testing, breaking, and coming out with all these in the combination of a new junction, of a new cross-sectional fitting from prosthetics to implantology. Thank you so much for your attention.
Thank you so much, Constantin. Your talks are always really inspiring to me. I just have some more ideas after I see your talks. We have some questions for you. Will the 3D printing of zirconia become affordable in the future? Because we know there is the technology, but it's I'm not sure how much it costs, but it's still very expensive, right?
The machinery is expensive, the material not. So, simple answer, yes. It will be affordable in the very near future, meaning that for central laboratories, it will be affordable for every dentist chair side, I doubt, in the next years.
Yeah. I think most users here, they have used the 3D printing for healing colors, for provisionals. You even mentioned long-term provisionals or even final restorations in your cases. Can you further comment on this one? Because I think this was a really surprise for a lot of the people listening, that you're printing final restorations to the implants.
Yes. Okay, just first from the legal aspect, we were allowed. But being honest, we have a complete contradiction here. On the one hand side, you asked me for evidence-based medicine, on the other side for innovation. So we will set up a research, maybe with 3 implants, looking about the long-term follow-ups in terms of mechanics and color stability for these materials, because they are not so long on the market yet.
Yeah. Cool, let's do that.
Thank you.
Thank you so much, Constantin.